Hey everyone, so previously we looked at recrystallization as a method for purifying solids, and today we're going to look at a method to purify liquids. So you can't really recrystallize a liquid at regular room temperature because it's a liquid, right? You'd have to have some really special apparatus and working conditions to do that. But we do have an easy technique to use, which is distillation. So we're going to set up a simple distillation, and then we're going to talk about the differences between simple and fractional distillations and when you might want to use one. So if you've heard anything about distillations before, what you're probably immediately thinking of is we're going to be boiling some liquid, and then we collect the liquid that boils separately from the original solution. So the first thing that we're going to need is our heat source, which in our case is a hot plate. So I'm going to go grab that. Okay, and I'm going to again be working on the jack today because we're going to be heating up volatile, flammable liquids. So what we want to be able to do is always control anytime we're heating, we want to make sure that we can easily remove the heat source in case something starts happening. So with this, we can just raise it and lower it with relative ease. It could use oiling maybe. And we're just going to go from there. So this is going to be our heat source. So we're going to build up from here, but we want to make sure there's a gap, right? We don't want to start here. There's no point in being on the jack. And the vessel that we use when we're doing a distillation is a round bottom flask. So it's just, looks like a round, a sphere with a little neck coming off of it. And we're not going to just place it down on the hot plate because that's not going to be a very effective way to heat solutions. So we're going to be dealing with heating mantles. You might have oil baths. In our case, we've got these metal heat blocks. This is a 50 milliliter one. It fits in nicely. Don't even need any sand. It hugs our round bottom here, and then it's going to transfer heat effectively and going on. So we need some sort of a gap, like I said, because we want to make sure that we can move the apparatus while we're heating. This is all part of the heating setup. So what we're going to do is we're going to clamp this to a ring stand. So I always start just by getting my round bottom and clamping it to a ring stand and then moving on from there. So it's a slight bit more complicated when you're working on the jack because the ring stand doesn't come up nicely underneath it. Maybe there's some kind of glassware somewhere that does do that, or not glassware, equipment, but that is okay because all we have to do is adjust our clamp. And what we're going to find is that we might have to move it a little bit, but with a few small adjustments, we're going to be able to get it there. So we know that it will sit on the hot plate. We might even push it back just a little bit, make sure it's not wiggly. Yes, I'm standing on my tiptoes because I am short. Okay. But like I said, we don't want it to start down in the heat source, so all I'm going to do is raise it up a couple inches. So we know that that height, or that distance from the ring stand is going to work with our heating mantle. So we're going to start from here. So the very first thing that I really want you to take note of is I used a metal clamp to secure my flask to the ring stand, and I started there first. I did that because the next thing that we need is our three-way adapter. So it might be called a three-way distillation head. We just call it a three-way adapter. I'm going to place that in my round bottom. A lot of times when you have joints like this, so let's say we're going to do something like this. We're not, but at the point where two pieces of glassware come together, you can use a cat clip. They're very nice. They help secure the pieces together, but they're plastic and they are not the most secure. Depending on how old they are, it might be a loose connection, it might snap, it might melt. So we never, ever, 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 ever put a cat clip here. We always use a metal clamp on the flask that we are heating, please. Plus, again, if I need to move pieces, I know that this is not going anywhere. This is going to be full of the boiling hot liquid. We want to make sure it's not going to fall, right? That creates an additional safety hazard in addition to whatever else might be going on. Maybe you just spilled something on hot plate smoking, nothing's happening here. This spills, now you've got another problem. Maybe this is just overboiling. You want to remove it. Maybe you just want to add something to it without taking off your entire apparatus. It's not, excuse me, fogging up a little bit. You know, it doesn't have to be these dire circumstances, but what this gives us is control. So please, please, please start here. Next, like I said, we have our three-way distillation head. That is where we're going to put the thermometer, but I'm not going to do that yet. It's kind of a fragile piece and I don't want it to break. So the next thing that we have is a condenser. So you have a jacket going along this inner tube, so it does go through all the way. Water is going to come in through one arm and we're going to direct it out through the other. We're going to use some hoses in the sink. This connects here. So the first thing you're going to notice is, one, it's not secure by itself, so we're going to have to secure it somehow. And two, it does angle a little bit. This helps because when the vapors come up, they're going to turn here, they're going to turn back into drops of liquid, and this is going to help them roll down and collect a little faster. So what I would do, because this is not secure, right, and we just talked about how ket clips are great additional points of stability, but by themselves, they are not perfect. So what I'm going to go ahead and do is I'm going to use another ring stand. Now, normally, I would try to keep this as I don't know, parallel, running the length of the bench as possible, but because I want you to see what I'm doing, I'm going to try angling it outward. This is not how I would normally set it up, but we'll see. Maybe I can kind of split the difference here. But the point is, I need to clamp this. So I'm just going to grab a ring stand. So with distillations, you'll typically be using 2 ring stands. And go over the cord. And now this one moves independently of the jack, so we can place a clamp pretty much wherever we want. So I like to turn the clamp so that it's got the 2 little fingers holding this. I think it, I don't know, I feel it gives a little more stability. It probably doesn't truly matter, but in case it's not the tightest connection, it's not going anywhere, right? And now, if you leave everything just a tiny bit loose, you can make small adjustments without having to completely open and close these every time. But what we can see is that we're not there yet. That's fine. We're going to move it up a bit. We're going to move it back a bit. Move it down this way. Okay, so we are almost there, but not quite. So what I'm going to do is I'm going to actually slide my hot plate over. I can slide this ring stand over. And now they can actually come up and meet. Okay, let's see, can I go? That's not too bad. Again, I would always set it up so that it is more going like this. I think it's a little secure. You have less chance of bumping it and messing into it. But again, I want you to see what's happening. So for today only, I'm just going to swing the ring stand out just a bit. Again, check that nothing's wonky. So now then we're going to double check that these are all secured. It's not going anywhere. And I'm going to see if I can maybe just inch the ring stand a little further towards the middle here. There we go. I like that a little better. Okay. Now, everything's good so far, but we want to make sure that these aren't coming loose right here, right? 'Cause it can pop loose still. We've provided stability. So now we're going to add our first cat clip. There's a bigger side and a smaller side. There's a piece of glassware going over the outside. There's a piece of glassware going on the inside. So bigger end on the outside. It'll only snap on one way. So now we can make sure that these joints are staying together. We want to make sure they're fully together here. There's no gaps because if there are, the vapors can come out into the airspace. 1, safety hazard. 2, you're losing your product, and that's not efficient and kind of a waste of your time, right? So vapors come from here, they go up here, they come into here. We need to catch them somehow, so we're going to use this vacuum adapter. So if you wanted to do a vacuum distillation, you've got an extra arm here where you could apply a vacuum hose. We are not going to adjust the pressure though. We're going to leave it open to the atmosphere. You never, ever, ever heat a closed system. So you want to leave this open, or make sure if you're working under vacuum, you've got all the correct connecting pieces. So for us, it's fine. There's an extra little dropper in the middle here. So when it comes through, it's going to be directed into here. This is just, again, another outer jacket. Again, now this, not actually connected to anything. It holds here, but this can fall. And in fact, when I set up my very first distillation ever, way back when I was in Orgo lab, I put this on here. I turned away to go get a ket clip. I let go, fell about this distance, shattered into many pieces, and it cost me like $25. So never walk away until you've secured it with something, right? Even if it's just a quick second to grab the connecting thing, right? And then finally, it's traveled all this distance. Now we want to collect it. So I've got another round bottom. This one's smaller because we're not collecting the full volume. That's okay. I've got another ket clip, and boom. Now we've got all of our pieces here. Again, I could technically swing some of this around if I needed to. Let's say I'll be adding liquid here in a minute, so we'll see how I can actually take this apart. So we're almost done and ready to start the distillation. We're missing a couple things first. So first, when we start collecting, so vapors will come up into here. They turn into a liquid here. As they condense, they come back down. We have our first fraction. We get the identity of that fraction based on the boiling point. So you're going to see that there are a range of different boiling points depending on the liquid or the mixture of liquids that we're dealing with in this experiment. So you want to measure those. You want to make sure you're measuring the vapors and not the liquid below, because they can be different. Right? This might start boiling well before we have any vapors up here. So that means the airspace here is just whatever our room temperature is. Right now it is 24.5 degrees Celsius. But if we have it above the joint here, then the vapors take this turn before they hit that. So you want it just below the junction there. So we're measuring the vapors that we are about to collect. So I like the top of the bulb to even with the bottom of the opening right here. Now you'll notice the adapter, so there's a glass piece and then a separate rubber piece that actually holds the thermometer in place. Okay, so it is two pieces. This does that. If we put the thermometer in there, there's nothing to actually hold it, so that's not useful. However, if we only have this piece, it sits on top of there, but it's open. And again, we're losing all those vapors. So the thermometer adapter is actually a two-piece. Now, anytime that we need to adjust glassware like this, we want to use small twisting motions. Keep your hands close together. If you go from here or like here, it can snap, impale your hand. This one's alcohol. There might be a mercury thermometer floating around here or there. So you just want to make small twisting motions. Check it. It's a touch too high. Bring it back up. Okay, I'm happy with that. So there's a little bit here you can't see. So if you need to check the boiling point of anything that's 30 or below, you're not going to be able to see it. But by the time you hit 35, you're above here. And it goes all the way up to 260. So this is going to tell us what we're actually collecting. That's all the theoretical stuff. Today we're just focused on the setup though. So the last thing that we need before we can actually put our solution in and start distilling is the water. It's not going to be very efficient if we don't have water cooling our condenser here, because it just might not ever actually recondense. It might just get all trapped up in here, not make it down here, and we're just spending more and more of our time stuck in the lab. So water always flows in through the bottom and out through the top. So you can see there's a slight angle right here. So this is kind of the bottom, or against the flow. So if the vapors are coming this direction, flowing this way, we want to go in the opposite direction. So I've got a hose. Yeah, you can just barely see. There's a faucet on the sink. It's got a hose already connected to it. You always want to check it's not cracked or got holes, anything like that. It's going to actually hold up. And we're going to come in through the bottom. So this is part of why I try to keep my setup close and perpendicular to the sink, because I don't want to have like 20 feet of hose to deal with. You want to make sure it reaches. And then it's going to come out here. We don't want this just shooting off into the air, right? So we need another hose. Again, try to find one that's not too bad. The downside of, organic labs is that it's full of corrosive things all of the time. So things like rubber tubing will go bad a lot faster than you really want it to. So always check before you use it. I don't really care for this one, so I'm going to go grab a different one. And once again, we want to make sure it's going to go from here. It's a bit short. Let me go try again. Oh, I found an even shorter hose. Let's keep trying. I realized that from a video production side, that was rather boring for you, but it does kind of mimic what it's like to actually be in a lab, right? You don't always have pristine, perfect equipment right at your bench. Sometimes you gotta go get it. So the point is to know what you're looking for. Okay, so connect it here. Throw your paper towels away in the garbage, not the sink. And then what I am doing is I'm just making sure that the hose is not going to lay on the hot plate at any point and that it actually hangs down into the sink. So before we ever start heating, we want to go ahead and check that the water works, that the hoses work and everything else. So you just turn it on slowly. It doesn't need to be fast or violent. We just need it to fill the condenser and continue to move. And now it does look kinked a little bit here, so that's an easy fix. We're just going to slowly rotate our condenser so it's a little bit more parallel to the ground, and that helps with the flow there. So you can see this is our flow of water. It's a little fast. We could slow it down. The value of slowing it down is if it pops off, it's less water to deal with in your face. It's less wasteful. We don't need, we don't need that fast of a turnaround in the water. Okay, so now we officially have everything ready to go in our apparatus. So I just want to recap here. We've got the flask that we're going to be distilling from. So this is the liquid that we want to purify. This is just a three-way connector, so it's connecting our flask, holding our thermometer so we can measure the temperature of the vapors. These vapors take the turn into the condenser where this cold water will cause them to recondense into a liquid. They roll down through this vacuum adapter right here. It's also called a bent Y adapter. It's the thing I broke. If you wanted to make it a vacuum distillation, this is where you would hook up the vacuum. Otherwise, you just leave it open to the air and it collects down into another round bottom flask. We've got yellow ket clips to secure the joints. Their primary stability comes from these metal clamps here. One last note before we actually start the distillation is that sometimes you have a very volatile liquid. This won't be hot because it's just hanging in the air, but sometimes you want to add an ice bath here depending on how volatile or how low the boiling point of the liquid you're collecting is. So this might be a place you would add an ice bath. Today, that's not going to be necessary. Okay, so this was how to set up a simple distillation, and then we're going to come back and look at actually running the simple distillation.